Hello and welcome to Science with Mrs. Blackburn. I just wanted to review with everybody for our upcoming test on Earth and space. And again, this unit has been about how the Earth behaves in space and why we see some of the phenomenon that we do on Earth because of what it's doing out there. So I'm going to do this in a couple of different parts, and this first part is about Earth's motion and seasons. So let's go ahead and get started. The first thing I wanted to talk about is how cool it is that the sun is 93 million miles away from us on Earth. That's a really long way, and we still feel its effects. We get enough energy from it to support life. If you've ever been outside on a really hot day, you realize that sometimes it doesn't feel like it's 93 million miles away, but the sun is going to give off so much energy that we see some pretty cool things and experience some really cool phenomena here on Earth. So let's talk about the first couple of things that we discussed in this unit that are pretty simple, but we need to know for everything else. We need to talk about rotation and revolution. Now, we know here on Earth we experience days. We experience daylight and dark, and that's because the Earth is going to be spinning. It's in a constant spinning motion, and it takes the Earth approximately 24 hours to make one entire spin. We have daytime when our part of the Earth is facing the sun throughout that spin, and we have nighttime when our part of the Earth is facing away from the sun throughout that spin. And as you can see on the diagram here, we actually have a little tilt to the Earth, which is going to be really important here in a minute. And so that little tilt means that there are certain times of the year where we're not going to get equal amounts of daylight, and we'll talk about that a little bit later. Now, the other part of this is going to be revolution. Right over here, revolution. It takes the Earth 365 days approximately to revolve around the sun. That means it's actually, while it's spinning, it's also going to be moving around in this direction around the sun. And so that's where we get our years. So we have 24-hour days. It takes it 24 hours to spin one complete turn, and it takes 365 days approximately to make one trip around the sun. Now, the rotation and the revolution are going to cause some things. That are going to be pretty cool. They're going to cause us to be able to see there are just certain effects. One of the effects of Earth rotating is, like I said before, is day and night, because during the daytime, that's the time that we are facing the sun in that spin. Night times when we're facing away. If Earth did not rotate this way, we would not be able to sustain life on this planet, because only one side would constantly be getting the sunlight, and that we know that's not the case. And then the revolution, of course, is going to give us our years, and it's also going to give us our seasons. And so we're going to talk about that next, because that's something that a lot of people have misconceptions about. So before we talk about that, let's talk about what causes the Earth to stay in its orbit around the sun. Now, orbit is the actual path that the Earth is taking. So when you say the word orbit, sometimes we use it as a verb. It orbits the sun, and that's fine. But just realize that the definition of an orbit is the actual path it's taking around the sun. So it's revolving, that's the motion. Its orbit is the actual path it takes. And so I like this diagram because it shows that it's the gravitational pull of the sun that's keeping the Earth in orbit. Something that I want us to notice here on this diagram is where that misconception that a lot of people have comes into play. If you ask 10 people, just random people, what causes our seasons on Earth, I guarantee half of them or more will say that the Earth is closer to the sun in the summer and farther away during the winter. And as we've learned in this unit, nothing can be farther from the truth. If you actually look, the Earth's orbit is slightly elliptical, which means it's not quite a perfect circle, almost between an oval and a circle. And if you look on here, July 4th, now we know that's the summer, okay? In that elliptical orbit, the Earth is farthest from the sun. Well, that doesn't make sense, does it? And over here, January 3rd, the Earth is closest to the sun. And we know that in January, for us at least, it's going to be really cold. And so that doesn't make sense. So there must be something else that causes seasons, and we know that there is. So, why do we have seasons? Let's talk about that. So if you notice, when you go outside different times of the year, you're going to have different angles of sunlight hitting the ground. In June, on this diagram, it shows that the sun's rays are going to be hitting from way above us, like right directly above us. In December, sometimes you notice that the angle of the sunlight's a little bit lower. I think that in December, a lot of times when you're riding in the car, the sun will be likely to get in your eyes because it seems like it's straight ahead of you. And so we notice that throughout the year that the angle of the sunlight is going to hit a little bit differently. And you might notice that at home through your windows, different times of year, the sun will come through your windows at different angles. And that is because of the Earth's tilt. Now, we said earlier that the Earth has that little tilt on its axis. And because of that tilt, we are going to see that different parts of the Earth are going to get different amounts of sunlight at different times. So basically, the sun's rays are going to hit very directly at a high density in certain places, and they're going to hit more indirectly in different places. So in this diagram here, you're going to see that the Earth is going to be tilted away from the sun, okay? That tilt is going to be going away from the sun, and the northern hemisphere, now we talked about that in class, the Earth is going to be separated into two hemispheres, the north and the southern, and the equator is going to be what separates those. So in this diagram, the northern hemisphere is tilted away from the sun. The southern hemisphere is tilted toward the sun. So if you were to count the number of little arrows in this model that the southern hemisphere is getting, we see the southern hemisphere is getting about 1, 2, 3, 4, 5 of arrows in this model. And how many is the northern getting? Only 2. So the sun is pointing toward the northern hemisphere, but the thing is the northern hemisphere is tilted away, so it's not able to get as many rays of sun. So this kind of explains why we have seasons. Now in this other diagram, we see different months of the year. So here, let's look at what's happening in December. In December, we see that this northern hemisphere right here is going to be tilted away from the sun, just like in this diagram. In March, if we look at it here, we are not tilted toward or away from the sun. It's kind of equal. Okay, both northern and southern hemispheres are getting equal amounts of the sunlight because it's not tilted toward or away from. But in June, look at this northern hemisphere. Where are we pointed? We are pointed toward the sun at this point. So we're getting more direct sunlight on that northern hemisphere, and that makes sense to us because that's going to be June. That's when we start getting warmer. And then finally, here in September, we see the exact same thing as we saw in March, only at this point, we're on the other side of the sun. But we're going to have equal heating of northern and southern hemisphere. And so these different times of the year, obviously we have our seasons, summer, fall, winter, spring, but we also have some pretty cool things happening on certain dates during that time. So I'm going to show this diagram a little bit closer up for you. So I'm going to try to use my pen tool a little bit more here. So in this first diagram, where we see the Earth's northern hemisphere tilted the farthest away from the sun that it can be, that's going to be called the winter solstice. So that's going to be our winter solstice. That is the time of the year where the Earth is tilted, or the northern hemisphere of the Earth is tilted the farthest away from the sun that it can get. During that time, we're going to have the shortest day of the year, and that's going to be around December 21st that's going to occur, and that's also known as the first day of winter. Down here, the third diagram down, you're going to see the opposite of this. The northern hemisphere is going to be tilted the farthest toward the sun as it can be. It's going to be angled the most toward the sun as the northern hemisphere can be. That, you guessed it, is the summer solstice. That's the summer solstice. And that is going to be your longest day of the year. That's around June 21st. And you're going to have more daylight hours. And if you can imagine yourself being in that northern hemisphere, tilted that way, you could see that it would take you a long time to get away from the sun's light. And that's why we're going to have the longer days. Now, the other two that we see here are going to be our equinoxes. We have 2 equinoxes throughout the year, and you can think about this day a couple of ways. Number one, the northern and southern hemisphere are both getting equal amounts of the sunlight because we're not tilted toward or away from the Earth. So equal amounts of sunlight, and also on your equinox days, you're going to have equal hours of daylight and equal hours of dark. So you're going to have a vernal equinox, that's going to be your spring equinox, and then you're going to have an autumnal equinox. An autumnal equinox. And I'm just going to draw an arrow for equinox because it's really hard to draw that. So those are your solstices and equinoxes that happen throughout the year. So as we can see, it is totally not the proximity to the sun that gives us seasons. It is that tilt. And here's another diagram just showing the same thing. It shows the Earth orbiting around the sun, revolving around the sun in that elliptical orbit, which you can see a lot better on this diagram. And you can see that tilt really well as well. So you can see that this is all based on what's going on in the northern hemisphere. When the northern hemisphere is tilted away, it's going to be winter. When it's tilted toward, it's going to be summer. Okay? And that tilt, if you notice, is going to stay the same throughout the whole orbit. Throughout the whole revolution, the tilt doesn't change. It's always going to be tilted. Fun fact, it's tilted toward what we call the North Star. Its scientific name is Polaris. And so anytime you look up in the sky and see the North Star, the reason why it's always pointing north is because it is exactly where the way our Earth is tilted. Our axis is tilted right toward that Polaris North Star. So This has been why we have seasons. You've learned about rotation, revolution, the Earth's tilt on its axis. We've learned about solstices and equinoxes, and this is just a reminder to make sure that after you watch this video to go ahead and study for the test. Make sure that you're looking over your study guide. You can use this video to help you complete those diagrams. So happy studying. Have a good day.